Welcome to This Explainer. Today, we're diving into one of the absolute biggest shifts in cloud data management, key-value databases. Just like the uncluttered design we're using today to keep everything readable and focused, this technology is all about stripping away the unnecessary and prioritizing pure, unadulterated speed.
Okay, let's dive into this. Here's our map for the explainer. We'll start with the NoSQL revolution, see how key value works, look at some real-world analogies, explore powering everyday apps, discuss the trade-offs, and finally, check out popular industry tools.
So Part 1, the NoSQL revolution, moving away from rigid databases.
Let me ask you something. Have you ever wondered how your favorite e-commerce app remembers your shopping cart literally instantly? Even during a massive holiday sale, right, with millions of people clicking around globally, your cart just doesn't freeze. How exactly does the app pull off that split-second retrieval without crashing the whole system?
Well, that brings us to Section 2, how key value works under the hood.
A key-value database is actually the absolute simplest form of a NoSQL database. It stores data as key-value pairs, where each key is a unique identifier used to access its associated value. And honestly, that's literally it. The operations are incredibly simple. You just use get to retrieve data, put to insert or update it, and delete to remove it. No complex filters, no complicated joins, just pure, focused speed.
Now, what's really interesting is the stark contrast between these two systems. With traditional relational databases, you have fixed tables, rows, and columns. Everything has to fit perfectly into that structure. But with key value stores, there is absolutely no fixed schema. The value can be anything. It could be a number, a string of text, a JSON blob, or even an image file. Because there's no strict schema bogging things down, key value stores are just phenomenally fast.
Let's move to Section 3, real-world analogies. Let's make this concrete.
Imagine you're walking around the mall and you decide to drop off your heavy shopping bags at a baggage counter. The attendant takes your bag, which represents the value, the actual data being stored. In return, they hand you a numbered tag. That tag is your key. Now, when you come back, you don't ask the attendant to go searching through every single bag in the room for your specific blue one, right? You just hand them the tag. It's a direct lookup. You give the key, you get the value instantly.
Or think about another everyday tool, the contact list, right there on your smartphone.
And this brilliantly illustrates how schema flexibility works. The key is the contact name, like Mama, and the value is her contact info. But here's the thing, not all contacts have the same structure. Mama might have a phone number, an email, a home address, and a birthday photo. But your landlord, you probably just have their phone number. The database doesn't force you to have empty, wasted fields for your landlord's birthday. It just stores whatever value you give it, right under that key.
Our final analogy brings in the concept of global logistics, courier tracking.
When you ship a box, you get a tracking number, so that's your key. The box itself is the value. But here's the really crucial part. The courier doesn't care what's inside the box. It can be books, a gadget, clothes, whatever. To the courier, it's an opaque value. And the database behaves the exact same way. It doesn't understand the data it holds. This makes sorting and retrieving lightning fast, but it does mean you can't ask the database to, say, find all boxes containing blue shirts. It just doesn't know.
Section 4, powering everyday apps, looking at real-world use cases.
Let's map out your daily digital journey. When you add items to a shopping cart, the app uses your user ID as the key to instantly fetch your cart items. On social media, your user ID pulls up your entire profile data in one quick lookup. In inventory management, a product ID instantly retrieves stock levels. And it does this without scanning some massive, bloated table of every product in existence.
But, it's also working really hard behind the scenes. Key value stores manage your login sessions, meaning they instantly remember that you're logged in as you click from page to page. They also handle caching. Think about when a video goes viral. The system caches it in a key value store so millions of instant requests don't end up crashing the slower main relational databases. It's a real game changer.
Section 5, the trade-offs, pros and cons.
So, the crucial point here is that businesses absolutely love this architecture for its incredible advantages. We're talking high performance, massive scalability, complete flexibility, and absolute simplicity. When operational speed matters more than complex analysis, this is for sure the definitive go-to solution.
However, we definitely have to look objectively at the limitations.
Because of those opaque values we talked about with the Career box, you end up with very limited query capabilities. You can't easily map out complex data relationships. If you need to filter, sort, or analyze the actual contents of your data across multiple tables, well, a key value store is simply the wrong tool for the job.
And finally, Section 6, Popular Industry Tools. Let's see what businesses actually use.
First up is Amazon DynamoDB. This is a fully managed, serverless database. Now, serverless just means the business doesn't need to manage the physical servers themselves. If a website suddenly gets a massive, totally unpredictable traffic spike from a flash sale or a viral post, DynamoDB automatically scales capacity up to handle it, maintaining that single-digit millisecond performance. It's pretty amazing.
Let's move to our next tool and see how this builds on the concepts we just learned. Redis. Redis is famously used as a high-speed caching layer. It basically acts like a lightning-fast shield sitting right in front of a main database, instantly serving up frequently requested data to keep the whole system running smoothly.
And this brings us to a final, really critical thought. If key value stores handle the blinding speed of your daily business operations, retrieving cards, loading profiles, and checking tracking numbers, what database will you use to run your complex analytics and reporting? That is the ultimate question for modern data architecture, and honestly, a perfect place for us to wrap up. Thanks for joining me on this explainer, and keep questioning how your data is built.